Okay, everyone. I mentioned that I'm going to be following along a step behind you at this point, more or less. So what we got to yesterday is we created all of the structural framework, and I said, okay, next step is to start doing the actual facade exercise, which we have right here. So the first step that I saw as my path forward, just right now for simplicity's sake, I'm going to do the slab. The slab is an element that doesn't necessarily engage the other geometry. It can inform the other geometry, but it doesn't engage it. So I saw that as kind of a simple thing to begin with. So that's going to be my first step forward. So, and I went through the sketching process with each of you, I think, or some of you yesterday, and for the most part, you all sort of had the right idea. What you're going to want to do is grab the edge that you use to create the slab and the truss. Basically, that edge is just going to get replicated, and we're going to use that edge as a set in order to generate a new line. So we're gonna break down the edge, get a center point, push it out, create an arc, loft the two, and then extrude it upward. That's it. And then we join the two. We join it to the slab. So where are those curves? They're right down here. This is essentially the original surfaces, right? So what we did was we deconstructed it here, and then we list itemed, and we grabbed edges 4 and 10 from the whole list. So 4 and 10, we actually can continue to use part of this, but I'm going to try and make this a cleaner exercise, and so I'm going to start a new list item. And I think what I want to do is I'm just going to grab all of the possible edges that I could, well, actually, I'll just grab one set for now. So in this one, I'm just going to use 10, or I'm sorry, 4. I'm going to delete 10. And that's going to be this edge right here. Now this process can potentially get a little more complicated if you're going to do an exercise on all 4 sides, because then you're going to have to break apart that list and structure it in a slightly different way. This way, I automatically grab all 8 of the surfaces that I could possibly need. And this right now is flattened, which means it's reading as 8 surfaces in a line. So if I was to do something like loft it together, it would just create a solid plane that lofts through all of these curves, but we're not there yet. Anyway, so this is my operative list item. I'm going to push that down there. And I need to take that curve and divide it by 2. And I'm dividing that by 2 because then I have the ability to grab this midpoint, and that midpoint is going to allow me to create my arc. So I'll list item on the points list output, and I'm going to use a list item of index 1. Which allows me to grab just the midpoint. So here's part of the more important operative function, and it's the fact that I'm actually going to move it. I'm going to move this point outward and then reconstruct an arc with it. So I'll go to transform, Euclidean, move, and this move is going to require a vector, and it's going to require the magnitude. So I'm going to have an amplify. So I'll go to vector, vector, amplitude. And so the geometry I'm going to move is going to be the list of middle points or midpoints. That'll go there. And then the vector is a little bit of a different story. I have to essentially find a vector to use that's going to be relative to the geometry itself. So in this case, I like to use a perp frame with a deconstruct plane, which allows me to place a frame on the line, and then I can move it out along the direction of that frame axis. So I'll do curve, analysis, perp frame, and I can actually do it along the edge. So I can go and pull all of these edges here in, and I'm going to place them along a parameter of, I think it'll allow me to do a 0.5. Maybe not. Oh, are these are vertices? No, they're edges. Not within curve domain. That's weird. Huh. Well, let me try this instead. I'll try multiple perp frames and see if this allows me to do it. Curve. And instead of n, I'm going to do 1. No, oh, number of segments is 1. Okay, that's fine. They're all going the same direction. But it's creating groups of 2. That's not ideal. I don't know why this didn't work. Did any of you have that problem on yours with the perp frame? Did any of you not have this problem? Yeah, I did yours a little differently. What axis did we use for yours? Hold on. All right, well, perp frames is giving me an error that I have not seen before, and I'm having trouble troubleshooting it here in the few minutes that I have. But there's another option I can use, and it's this one here called plane normal, or any one of these kind of align plane functions could work for you. A few of them will work for you anyway. But this one creates a plane from a line and a point. You can do it with 3 points or line and line. I'm going to use plane normal, which basically means that I can take these curves and plug them in as my axis, and it's going to reorient it in order to align it to those curves. But then I also have to actually place them somewhere in space, and so I'm going to place each one into their respective locations. Oh, whoops, wrong one. I'm going to take this one. There we go. Now I only have one. Okay, so that's a little bit of a cheat. It's kind of like hacky. Like, you don't want to do that too frequently. It's just because I have that weird error I haven't seen before. So anyway, from here I'm going to start constructing my extrusion, but I need to look at the direction my planes are going. And I know you guys can barely see that up on screen there, but the green axis is going vertical, and the x-axis is going in toward the centroid of my slab, or the center of my slab, whatever. So essentially the way that I want to move this is in the negative x direction, because the red one is the x-axis. So I'll have to deconstruct this plane, and I'm going to use the x-axis, right? So I plug this in here, and then I have to give it a numerical magnitude. So that numerical magnitude, I'm going to say it's anywhere from 0 to, I don't know, 4 feet, so 4.00. And I'll move it, oh, it needs to be a negative, sorry. Math, operators, negative. There we go. All right, so now you can see that it's kind of sliding outward like that, which allows me to take, using this point list, I'm going to use the first point, the that middle point, and then I'm going to use the end point. So essentially, I can use these lines, and I'm going to deconstruct that curve using endpoints. That gets me a start, an end, and then these are my middle points, so I have to reconstruct it using those. So I'll do a arc 3-point, and I'm going to use my start point, my midpoint, and my end point, which gives me that curve. And I think the last part that we need to close it out here is just to do the loft. Okay, so the arc actually created just the outer edge. I need to loft it to the inner edge. And so that's going to be the list item curves that you see right here. And that part's really simple. Let me move this so it's a little clearer. I'm constantly reorganizing this stuff. There we go, that'll be kind of clear. So I'm going to go to Surface, Freeform, and Loft, and it's going to borrow the A, the resulting arc, plug that in, and the list item here, which are my curves, and hold Shift in order to add both lists. And it gave me an error somehow. Why is it doing that? Oh, because they're individual. Hang on. So my suspicion here is that it has to do with how many levels of branches we constructed in order to generate this list, and they're not speaking to each other because there's a discrepancy between how many branches it's reading. So take a look at this. This is the first time I think I'm talking through this stuff with you, and in fact I'm not the expert on this yet. It's just a suspicion right now. See how the index values on the left say 0, 0, 1, 0, 0, right? There are 5 digits here. And then if I go back to the list I'm trying to plug in, there are only 4. So essentially that means that it's been constructed, deconstructed, and reconstructed a number of times in order to generate that geometry, and so the list has branched up to a new level, or a different level than the other list, I think. So what I suspect we can do is to flatten it and then graft it, and then it should potentially be able to work. But actually, maybe I can just flatten this whole definition. How many arcs does that create? It creates 8. Never mind. So I'm going to try using just kind of an external flatten, and then that's not the flatten I wanted. Whatever. And then if I graft it, I'm hoping it'll come back to, there we go, 0 and 1. Okay, so you guys see that? See how there are only 2 indices there? Let's pull that up. And then this one here, I can just flatten on the output and then graft it. And now you can see that there are only 2 indices, right? So it basically like collapses all of the history of that tree branch structure into a new structure of lists. Okay, it's kind of, again, it's kind of hacky. It's not generally the way it's supposed to go. So I suspect now when I plug them in that they should work properly now. There we go. They are working properly, however, they're going, see how one surface is darker than the other? I think that has to do with the order that I put it in. So I'll put this one in first and this one in second. And there you see it's more red now. Okay, so that's good because the normal of the surface is facing the same direction, so when I extrude it, I won't have any reversal issues. Questions?
Yes. When I tried, it just created outside rings.
It did what?
It created outside rings.
Oh, okay, I'll have to come look at yours specifically. Just a moment.